Okay, so I think this screen is visible to everyone. Let slowly we will start. Uh, so today we are going to start with the chapter number 3. Okay, in the chapter number 3, what we are going to discuss, we are going to discuss that what is the programming of the basic computer. Okay, up to this semester, what we have discussed like. Now, what is a different type of the logic functions are there? How their common bus system is going to be arranged? What are the instruction cycle? What are the design of accumulator? How that accumulator is going to be controlled? If there are different functions of the accumulator, then how their control logic block has been designed. Okay, what is kind of the control signal generator, and what are the timing cycles are there? Such type of the topic we have discussed up to this semester. Okay, so in this third chapter, what we are going to discuss, we are going to discuss that what is the hello? Yes, somebody has question. Hello. Okay. Okay, Canvas practice section. Yeah. Dhruv. Okay. I'll got that. So first, we will go with that Canvas practice session, and thank you for reminding me. Let me open that Canvas, and we will see that what are the stuff that we have given. Okay, so if I'll go to that basic stuff, that there are two question I have given. First question was to design a 16-bit full adder 16-bit full adder using a half adder, okay, or you can say using a full adder, you can design it. So first, let me go with that 16-bit full adder circuit. So if you simply search on the internet, you can get the idea like what is a 16-bit full adder. That 16-bit full adder will be look like this one, you can say also. Yeah. Okay. So this is a 16-bit full adder in which you can say there are a 16 different we can say different block of the full adders you have, and in every one they are having a 3 input A0, B0, C in S0. Whatever the carry out, which will go to the second full adder, then again A1, B1 full adding S1. And the same thing you are doing, like first you do the addition of this both one, you are adding the carry, and whatever the result going to be generated, which is S0, and carry you are forwarding to the other. Okay, so this is a simple, if you have written a such type of the 16 blocks arrangement, like you have using a full adder 16 times, and you have generated this complete block diagram, so that is also the okay, that is the first possible answer. Second possible answer that majority of the student has tried, that they have written as a half adder. Okay, so what you can do, like you all know that if I can say half full adder using half adder. If you can say full adder using half adder, so this is a block diagram, or this is a stuff which is related to a full adder. But in full adder, you required such type of the 2 to half adder. So instead of this one block diagram to do the full adder, instead of this one full adder diagram, you have used such type of the separate 2 half adder, and then you have make it as a full adder, and such type of the 16 box if you have written, then also this is also the right answer we have. Okay, so इसमें क्या किया होगा आपने? What you have done? You have designed a 2 half adder, okay, to make one full adder, and such type of the block you have repeated 16 times, and then overall answer is also going to be right over there. Is it okay? Understood by everyone up to this particular point? Yes or no? Somebody please reply me over here, please. Hello?
Yes, sir.
Okay. Third possible answer that we can say 4-bit full adder. If you can found from the internet, there are a 4-bit full adder circuits are also available, which will be look like, let me show you. Yes, which will be look like this one also. Okay, We can say this is a block diagram of IC name is a 74LS83. Okay, so under this, this is a complete 4-bit full adder circuit is there, and such type of the 4 ICs you have placed in a parallel, and in each of everyone you have given 4-bit. Okay, so we can say 4-bit in first, then 4-bit in second, then third and fourth. So we can say overall it's a 16-bit adder, and you have cascaded, like you have cascaded this 1-1 block diagram. Likewise, you have cascaded such 4 different IC of each of them are a 4-bit full adder. Okay, and if you have written inside of this diagram will be either this one or either this one. Okay, so we can say whatever the 4-bit full adder mentioned over here. So how 4-bit full adder going to be made? 4-bit full adder can be made by the arrangement of 4 full adder, like is this one. And how the full adder is going to be made by half adder? It can be made by the internal circuit like this one. So if you have written a such type of the pictorial diagram in which there are a 16 inputs are there of A, 16 another inputs are there of B, as well as there are a 1 carry in, 1 carry out, and 16 sum output. If such type of the diagram you have, and in which you have used any of these 3 kind of the concept, either 4-bit full adder based circuit, or half adder based circuit which is repeated 16 times, or full adder based circuit which is also again repeated 16 times. So that all are the possible answer of that first question. Is it okay with everyone? So can you tell me like what are the stuff that you have used so I can get the idea from that? Somebody has raised the hand. Yeah, Om Joshi, tell me, Om. Hello, Om, tell me. Yes. Okay. Anybody having any thoughts to add over here, or any confusion? Like I have not got this, or this is a question that which is acceptable or not? Sir, in question it's a 4 half adder circuit. Okay, you can say like that. You need to consider that 4 half adder circuit, and using the half adder circuit you can create a full adder now. So 4 half adder circuit, from that you can create a 2 full adder. Likewise, you can repeat it 8 times. So if you have just do that stuff also, I am not any problem with that. Dhruv, is it okay, Dhruv? Like 4 half adder, you can make 2 full adder, and that you need to repeat 8 times. So it's a 16-bit adder. Likewise, you can also present. But make sure in a 4 half adder, you are having kind of the 2-bit of the input, and there are a 2 some output must be there. Okay, that type of the diagram you need to make. So that as a session is already open for everyone. If you want to modify it after this one, you can also modify it and then you can re-upload it. Is it okay? So this is the answer of the first question. Let me go with the second question. I think nobody having the doubt in this one. Just a second, just a second. Yeah, so we will move for the another question. So you need to simply search on 4-bit multiplier circuit. Okay. So one of the best thing that I'm always going to use to see that 4-bit multiplier circuit, which is look like this one. Okay, in which you can use a 4-bit full adder. Okay, like this one. Okay, as well as you can use a several AND gate, and to do the binary multiplication, 4-bit binary multiplication, you can use the such type of the diagram over there. Okay, so by looking to that diagram, how we can say that this is the our 4-bit multiplier. Okay, so can anybody tell me, when you are going to multiply a binary number, what would be the process? Hello, by opening the mic, can you tell me how you can multiply the 4-bit binary number, so we can get the answer from that one? Hello, please open up your mic and tell me how you can make a 4-bit multiplication. Do you know the process? Hello everyone, tell me what is a
As in
4-bit?
4-bit multiplier.
Yes, Mahek. Yes, 4-bit multiplier. Binary 4-bit multiplier. Let's take 1000 1111. How you can do that? Multiplication of this both 4-bit number. Hello, tell me please. Let me take it over here into the one particular box and let me present it over here. Okay, new slide, and let me put it into the presentation mode, and let me take the pen and let we will do. So I am having a 1011. Sorry. So I am having the two number 1011. Okay, and I am going to multiply with the I am going to multiply it with the 1101. Okay, so now how I can multiply it? Can you tell me? First, I need to start with which number? This one or this one? Hello?
One from the left.
Yeah, you need to start with the stuff which is a number 1 which is mentioned over here. So what you need to do, you need to multiply this 1 with all of them. So answer will be 1101. Simple. Now what you need to do, you need to shift one bit. So you need to put a 0 over here. Then you need to multiply with this 0. So answer will be 0, 0, 0 and 0. Okay, so I can say there is an extra 0 is over here to make the addition perfectly. Now you need to shift 2 times. 1, 2 times. And you need to multiply this 1 with the rest of the one. So answer will be 1, 1, 0, 1. Is it true? Likewise, also you need to put extra 2 0 over here. Then what you need to do? Again, you need to shift 3 times. Why? Because you are at the 4th position. You need to shift 3 times. And you need to start with here with the multiplication of this one. So there is a 1, 1, 0 and 1. Okay. Now what I need to do by adding this extra 0 and all thing. Now what I need to do? I need to do the addition. So if I do the addition, so you can observe that whatever the first bit coming as the answer, which is directly coming over here 1. Okay. While there is a second is there, which is coming as a answer 1, but by considering that second multiplication into the consideration. So that's why that answer is going to be 1. Then in the third condition, what you need to do, you need to check for this also and for the third number also. So it will be an addition of these 3 numbers. So answer will be 1. Okay. So by looking to this diagram, if we can see our diagram of the multiplier and shifter, you can say that shifting is going to be done by using this AND gate. So what we can do, you simply doing the multiplication is nothing but making an AND gate, make them into the AND gate 1 0 0, 1 1 1, 0 1 0 like that. So likewise, all the numbers, first let's take B0 to B3. In our case, over here, if we can say this is a B and this is a A, so I can say this particular number going to multiply with all the above number. So I can say, if I am having this stuff, so I can say that whatever the first number you have in the second digit, it's getting multiplied with all the B0 to B3. Okay. And whatever the first answer has been came, whatever the first answer came over here, which is directly result in terms of the answer. Okay. So you can say this B0, whatever the multiplication done over here, which is your first answer C0, while rest of the 3 bit going to pass with the addition of which number? Addition of next multiplication number. And next multiplication number is your second digit is getting multiplied with all the 4 digit, and answer going to be, you can see, so answer is going to be added over here. And over there you have putting an extra 0 for that. And where is the extra 0? We can say this is the extra 0 we have put it to do the addition of this, all these numbers. Okay, I can say especially this 4 number. So for that 4 number, I am putting extra 0 over here. Okay, this is extra 0. That's the same thing put it over here. Whatever the answer it will came, last digit S0 is result into the final answer because it's not going to participate in anywhere. Rest of the three number go to the third, we can say third stage of the multiplication. While A2 number get multiplied with all of them, and then it's going to be added, and same process that we have followed over here. So S0 will come as a result. Rest of the three will go with the fourth stage of the multiplication, and whatever the answer we will got, that is going to be your final multiplication answer. So we can say you have done a one by one shifted by giving the feeding into the individual logic gate while you are using a full adder circuit over here. Is it okay with everyone to understand this particular stuff? Left one, you can say, yes, you need to make it left 1, 1, 1, 1 like that, padding the extra zeros. And finally, you need to do the addition of all of them. Anybody having any doubt in this, both of the answer? Like if you have done such type of the diagram, it would be right. You can also modify it after this explanation. Anybody having any questions? Any doubt? Clear? Okay, good one. Chaliye. So now we will start with our regular topic of discussion, which is I can say, let me delete this slide, delete this stuff. Yeah. So we are at the topic number 3, chapter number 3, in which programming of the basic computers we have. Okay. So under the programming of the basic computer, what we need to discuss? We need to discuss that what is the first of all introduction of that. Okay. Then we have, there are a machine language is going to be there. What is the machine language related to that? The assembly language kind of the task. What do you mean by assembler, program loops, programming arithmetic and logic operation, subroutines, input-output programming. So these are the sort of topic, okay, related to the programming that we need to discuss in this COA subject. So we will start with that in introduction. Those concerned with the computer architecture should have the knowledge of both hardware and software, because there are two branches influence each other. Okay, we can say if you only know the hardware, okay, that's not going to be enough. You also need to understand that which type of the software going to be implied on that, which actually make your system work perfectly. So what are the software that you are designed for those hardware? Okay, that is also kind of the major part of that particular system. Okay, but without knowing the any hardware perspective, you cannot directly design a software for that, because you need to understand that what is the software part it will require, what type of the instruction it is supporting, and according to that, which type of the software I am designing. So we can say that's the combination of hardware, software, both are required and both branches are influenced to each other. Okay. So what are the basic instruction set? So the instruction set and all the things we have discussed kind of the many times into the chapter number 2. There are logical operations are there, there are arithmetic operations are there, there are register transfer operations are there, load are there. Okay, we can say interrupts are going to be there, input output instruction are there. So there are several instructions are there, and according to that there are different codes which is going to be associated with this one. Okay, so that we can say there are a different hexa code which is related to that particular symbol. Okay, and according to that hexa code which is generating from your system, okay, whatever the hexa code generating from your system, from that 16 bit of the data, from the 16 bit of the data, it going to be fetched by your, like you have a process of fetch, decode and execution. So whatever the 16 number you have given for CLA or for any sort of let me take a laser pointer first. Oh, sorry. So if you can take any hexa code, okay, like if you can say for the CLA there are a 7800. So this 7800 is your 16-bit binary number, you can say. Okay, and along with that 16-bit, that 16-bit going to be fetched first and decoded into the 3 part. First part will be says that under the which condition this particular code is lies, whether it is lies as a memory reference instruction, the register reference instruction, input output reference instruction. If there is a memory reference instruction, then direct memory address, indirect memory address. According to that condition, it will define their task. Like if it is under the memory address, so there will be kind of the direct or indirect process is going to be there. So I can say those particular stuff related to I need to execute, and such type of the symbols and their terminology going to identify. If there are related to input and output, okay, or if we can say it is related to the interrupt. So these are the some of the stuff which is code has been defined accordingly. Okay, so that's why you can say whenever there is a AFF over here, it means 12, 13, 14, 15. These 4 digits are 1, 1, 1, 1, and we can say of this all the 4 digits are going to be 1. So this is related to input output information. First digit is going to be 0, but rest of the digit is going to be 1, 1, 1. It means 15 going to be 0, but 12, 13 and 14 is going to be 1, 1, 1. Then it is considered as a register, we can say register reference instruction. So we can say at that time you need to identify or you need to do the structure related to the different register, like clear that, complement that, and so on. If that last digit, that 7800, if out of that one, if this is not going to be 0, we can say if this is not going to be 7, but between 0 to 6 anything, then we can say there are a different symbol is going to be identified for doing their memory reference instruction for that. Okay, so this is the overall basic identification of different instruction from the hex code that is actually allocated to them. Whenever you have doubt, I'm again say that you please interrupt me and tell me that, sir, I have not understood this, that then I'm going to explain that one. So we can say, what do we mean by machine language? Okay, so we can say that's a program list of instruction or statement for directing the computer to perform the required data processing task. Okay, so we can say program list of instruction or statements for direct computer to perform the required data to processing the task. If you are processing any particular algorithm or any particular task or any particular thing was that, you are writing some of the instruction for that. So there are a list of instruction that you are allocating for such particular kind of the task, which is considered as a, we can say that's the machine language you can say. But for that, various type of the programming language we have. Okay, under that, various type of the programming language which ultimately do the data processing task. But that are the hierarchy of the program language will be machine language, assembly language, high level language. Okay, so machine level language will be binary code, octal or hexadecimal code. Assembly language will be kind of the symbolic code, and high level language that you are giving as a C or C++, likewise you can say. So I will give you the simple example for that. We have discussed in our laboratory, if you have remember that in our laboratory we are using a GNU SAME 8085, and we are writing a we can say symbol of each and every task. Like if you want to load any register, then you are using move. If you want to take data from any external memory location, then you are using LDA. If you want to do the addition of that, then you are writing ADD. So such type of the symbolic code we are writing, and that we can say the assembly language, in which there are a symbolic code we have used. If you have remember, then for the same type of the instruction, right now we are working on online mode, but as I have told you in a first lecture, that if we are in the offline mode, so you are going to perform this particular task in a hardware. Okay, so we have Dyna 8085 kit is going to be there. Under that kit, I have given you the explanation that whatever the code you are writing, let's take you are writing the code of flipping a 2 number. So we can say like flipping a 2 number is going to store the specific type of the hex code in a different memory location. Okay, let me go to that one. So yeah, so whatever the code that I'm going to write over here, so you know that like it is going to be stored in the different hex code as a different data. Okay, that all you have experienced. Like whatever the program you are writing over here, that is ultimately going to reflect it after running this program. Okay, so this is a process we are doing, that we are saying we are doing we are using an assembly language program. Okay, What do you mean by machine language program? So for that, if I'll go to the experiment list, and I will tell you that under the experiment list, I have show you already one particular stuff is going to be there. Let me just go with that one. Yeah. So in a first experiment, I have give you idea brief on that, this hardware kit. If you have seen this hardware kit in a first lecture, so I can give you the idea from that. So in the hardware kit, what you have, you are having one kit which is named as a Dyna 85 kit, under which what you are writing, whatever the mnemonics or whatever the assembly language program is there, you write their respective hex code. Like if you have written MVI A44H, so what would be the hex code for that? Likewise, you are writing a address over here, and in front of the address in each block, you are writing this hex code in front of each and every instruction. And you are making list of them, like this is a first hex code, this is a second, then there is a third, fourth. After identifying those hex code, you load those hex code into this hardware. Okay. You are not writing any MVI move, no, you are directly loading the hex code in your system. So that we can say, when you directly load the hex code in your system, that is going to be considered as a machine language code, while you are directly giving either binary code or octal or hexadecimal code. Okay. Apart from that, if you are writing any third level language, which is a higher one, like you are not using any move, but you are directly mapping it to some hardware level, like I can say that using a C or C++ embedded C. Like if I'll tell you that if you have heard about the Arduino, so we can say Arduino is a one type of the microcontroller based device. Okay, but you programming them by using an embedded C platform. Okay, in embedded C platform, which is a similar as a C platform, while you using a for we can say kind of, you can make a loop. Okay, while structure is there, subroutines are there, that all the things you can do with that. Okay, so these are the high level language which we can consider as a compiler, assembler, and the machine language code. Okay, so each symbolic instruction can translate it into one binary code and instruction. This translation is done by the special program called as a assembler. So whatever the stuff that you have writing in a compiler, that going to be converted from symbolic to any hexadecimal or any binary number, that is considered as assembler. It will assemble all the things and arrange in particular sequence, that this is the arrangement of the program, and then there is arrangement is given to the your microprocessor and controller, and that arrangement, it is in terms of hexacode or binary code, which is a machine language level code is there. Is that okay? Anybody having any doubt in this particular stuff? First, you need to start with this basic fundamental. Then we will go with the one by one stage, and then it's going to be clear with everyone. Is it okay with everyone? Okay. We will move forward for the next question. Whenever you have doubt, you please interrupt me and ask me the question. So what is a comparison of the language? So as I have told you, this is a binary program to add the two number. So there are some instruction code. If you can say there are a hexa program is there, so it will be look like this one. If there is a program with the opcode, so that's going to be like this one. Okay, LDA something, add, STA, hold, and like this one. Assembly language program will be like a ORG, okay, and we can say with LDA, add, STA, HLTA. So this is, we can say, if we can say in a hexa or in a binary, so it will be look like this one. If related to opcode, or symbolic or mnemonics of that particular task, so it will be look like this one, and we are very much experienced with that, okay, because we are using our laboratory session with this opcode based stuff. If we can say like what are the rules of the language, so rules of the language will be, we can say, label may be empty or it may specify the symbolic address. Like instruction field, whatever the instruction field are there, that instruction field may be empty or it may be specify a symbolic address. Okay, what are the instruction field we have? Like specify the machine instruction or pseudo instruction. Comment field will be maybe empty or it may be include the comment. So over here there are three stuff we have: label, we can say, and we can say code, and there is the comment. So what we can say label, it will be symbolic address, like what is the address of that label. An instruction which will specify the machine instruction or pseudo instruction, that what instruction you need to perform, and the comment field which will be either empty or it will include the comment. So you can say when we are doing the programming, you are writing, you are doing a practice like that, whatever the code you are writing, in just after that you are making the comment of that, like this is a comment related to this particular subroutine or this particular part. So what you are saying over there, that this comment is just a simple specification of this one. Okay, so three stuff we have, like location will be there, instruction will be there, comment will be there. So location wisdom is their memory location, what are the instruction associated with that over that memory location, and what are the comment or what is the task actually performed by this instruction, that is under the comment. So these are the basic rules of the language you need to apply when you are using assembly, or normally when you are using a C code, any code. So always that your teachers and your faculties are suggesting that whatever the stuff you are writing, you please write a comment just after that. So whenever you're going to debug or whenever you understand those stuff, you will get the better idea that where actually the problem is there, what is the meaning of this code. Because if you have written 1,000 lines of the code, and at the end if you have forgot that this particular routine I have called at which line, so if you have written the comment on that section, so you can directly get the idea that this is comment for this particular stuff, okay, this comment for this stuff. So these are the basic rules that generally we need to follow. But in assembly language, label, instruction, and comment. So label will be either symbolic address or it might not be specified, then instruction, and then there is a comment field. So in assembly language, the syntax of binary code, assembly language, okay, each line is arranged in the 3 columns called a field. First, which is a label field, as I have told you, that may be empty or maybe specify the symbolic address, consists of 3 characters terminated by the comma, like that. Then instruction field, which is a specified a machine or pseudo instruction. It will be like ADD, OPR, so direct address of, we can say, memory reference instruction. ADD, PTR, so indirect address. Okay, we can say register reference instruction, input output instruction, pseudo instruction without operand. Likewise, the instruction field is there. And then comment field may be empty or may include the comment. Okay, so we can say, as I have told you, there are 3 stuff we have. As I have told you, there are a location. Okay, then there are a instruction with the comment. We can say in location, this is a stuff going to be loaded, and this is a comment for the. So these are the stuff is going to be there, as well as there are some symbolic representation also going to be there. Along with, they are not writing memory location, but they are writing some kind of the register reference and with the comma. Okay, so there are a different way of assembly language is going to be identified, or it's going to be arranged to understand the stuff that what actually this program is doing and how their binary or hexadecimal translation is going to be there. Okay. So next we have what is a symbolic address. Okay. In the label field consists of 1, 2, or 3, but not more than 3 alphanumerical characters. So first character must be letter or alphabet. Next two may be a letter or numerals. Symbolic address is terminated by the comma so that it will be recognized by the assembler. Okay, so whatever the language rule, symbolic address we can say, so what would be the symbolic address? We can say it will be like this one. Okay, so over here in a symbolic address we can say, yes, so if I can say there are whatever the symbolic address is going to be there, it's either 1, 2, or 3, or we can say alphanumeric code, or we can say binary number, whatever it is. So it will be is either into the 3 different numbers, and it's going to be terminated. Okay, so I can say whatever the operand is going to be there, whatever the kind of the stuff that you want to operate on, accumulator, register, B, C, you can say in assembly language it will be like look like this one also, or with the 3-bit number of this one also. So that's why it is saying like that, rules of the language. First character must be either letter or alphabet. Okay, anything will be there. Next two may be either letter or numerals. Then symbolic address is terminated by the comma so that it will be recognized by the assembler. So we can say whenever you are doing assembly language programming, okay, at that time, how you need to define that what is your first three character is there, okay. According to that first three character, what would be the kind of the process I need to do, and that process need to do on which stuff, either in, we can say, in kind of any direct register or any numbers like that, okay. So I can say what are the different field are associated with it. So we can say three stuff we have discussed, okay. Like we can say direct memory address, indirect or direct non-memory reference instruction with IO or register reference, pseudo instruction without the operand. So it will be look like this one. MRI occupies the 2 or 3 symbols separated by the space, like CLA. Then there are operands. So we can say it will be either the no operand will be there. Either I can say add or any operand will be there. Add and any other operand will be there. So that type of this stuff is going to be possible. Like you write this stuff, you can say just a simple one code and there are no operand. You can say like that. If I'll simply say that if you have said add B1, so we can say add is there while B1 is there. So there are a register reference you have given also, and this stuff that you want to do as addition that you have given. But if you have simply said that CLE or HLT, RST, so that all we can say there are a non-MRI, not memory reference instruction based stuff. There are just, I can say without operand instruction is there, pseudo instruction. So that also you can write over there, and we have very much, I can say, that we have familiar during our programming. Okay. So assembly language, which is that instruction field, their comment, and over here if you're writing their hexacode, so these are the kind of the three field we have: their location, their I can say that stuff, or we can say their instruction, and then we can say there are comments. Okay, so if we can go further, we can say, okay, so what are the stuff we have? Slash recognized by the beginning of the comment, comments field will be here. So over here, there are some of the example of the assembly language. Okay. So over here, it will be look like that. Right now, we are writing all the stuff related to this one. Okay. That dot and such type of the stuff we have not yet done, but it also going to be possible. What do you mean by pseudo instruction? Pseudo instruction, as I have told you, like it's a ORGN. So that's example like hexadecimal number N is the memory location for the instruction or operand listed in the following for the particular line. Okay, so we can say whatever the memory location is there, hexadecimal number of that one. So instead of writing any number, instead of writing any register, you can directly allocate their memory location, like we have done in our stuff like move A, M. So M is not any other register, but that M is, we can say there are a directed number or directed address which is specified by H and L pair. Okay, so that's going to be a pseudo instruction, I can say, as well as there are AND denoted the end of symbolic program, signed decimal number N to be converted into the binary, hex and hexadecimal number N to be binary. So we can say there are a pseudo instruction that directly applied on the number or in the memory location. So this is a program is there, program for assembly language program to subtract two numbers. Okay, so first it will start with the origin at the 100, then load with the subtrade head into the accumulator, then complement that, then that increment of that accumulator, then add we can say minute to SC, then STA store their difference, then hold, then we can say again decimal, then subhand, then hex. So these are the list of the code which will says that what are the stuff that you are using. Okay, like you are using a stuff, you are loading some program, you are giving some instruction that you need to start with this particular number from this location, then you load some number over there, you can make the complementary of that increment. So we can say these are the pseudo instruction, we can say they are not having any operand. It's directly going to be performed on specific designated register. You don't require to give any other stuff with that. It's directly understand that if the instruction will come, I directly need to process this stuff on accumulator only. Okay, but whenever it is going to be related that any particular number, so that number will be that number is going to be identified by the a different register that you have mentioned, either MIN, DIF, and that MIN is defined as a, I can say DEC 83, sub DEC minus 23, difference is X0. So likewise, we can say whatever the program that you have written and whatever the definition of that we can say it's stored at somewhere place. MIN is stored over here. We can say subtract, whatever the subtract you need to do, that is stored over here. Then whatever the difference is going to be stored over there. So I can say your program actually is running between org to hold, but the location where you are taking this sub, which is over here, you are taking this add another number, which is stored over here. I can say in hex, which is that difference, whatever the store difference of this both number is stored over here. In another word, you can say whenever we are doing the programming, like you have experienced the programming of exchanging the two number. Okay, so at that time, if you have remember, I have give you the instruction that one number is going to be stored over here, second number stored over here. So our program is going to be run between something 0 to, let's take 0A, but actually your program is going to be end after this one. Why? Because over here you have occupied some number to store your data, and then this data come to your kind of the processor, it will process, and then it will reach to their destination address. So we can say whatever the value I have written up to the hold, whatever the value I have written up to the hold, which is going to be stored up to 0 to 9, for example. But the number that I'm processing on that, which is stored in a AF or 10. So I can say these are the two stuff we have that you can relate it in this our explanation stuff. Okay, so your program actually starting from 100 and it goes up to hold, but actually whatever the data you are processing, sub, MIN, DIF, so it's stored at the MIN location sub. So that will be either location or it will be something, we can say there are a name I have given. Like you can say this is a, when you are defining some variable, you are saying like that. Like there is we can say a integer on the main program, like just after the header and just below the header before starting your main instruction, you are giving directly the global variable, you can say. So that you are defining into one particular memory location, that this value, if it is used in any way, anywhere in the program, so that value I need to consider. So likewise, you can relate it that. So this side either it will be kind of the numbers, or we can say there are we can say mnemonics, or their identity is going to be there. Is it okay up to this particular stuff? Yes or no? Any question? Kunj, Astha, Mohammad Hafiz, what's your opinion? Have you understood this stuff? What is the meaning of this assembly language program? How we can read that? What is a basic process behind that? Have you got the idea, everyone? Yes or no? Devans Valara is saying. Okay, so we have approximately 13 to 12 minutes of time, and as per our tradition, what we need to do, you need to write a detailed summary of this particular lecture, and you need to write down that what the under the assembly language we have seen, what is the stuff that we have discussed for that practice question. So write the detailed summary in the chat box. Then after, you please write your enrollment number and name, and then after you can if you have any question, you can ask me during this last 10 minutes. Otherwise, you can leave and wait for the next lecture. I am open for the doubt for 2 days. Parth Kanapra, Parth, શું કરીએ આપણે? Like તમે જ્યારે તમારી lab ક્યારે છે Parth? When you have lab? Okay, Parth. So if you have lab, in that lab, just remind me. Sir, this is the stuff is remaining. Kindly open for that. So I will open for that lab and you will directly upload over there. Okay. So whenever you have lab, just remind me. I will open for any pending submission. So now you have 10 minutes of time. Everybody write a detailed summary, and mind well, if you not write a detailed summary, I will put absent for you. So write a detailed summary in the chat box that what we have discussed. Then after, you write your enrollment number, name, and then you can go. So over here 65 students are there. When I'm explaining those practice session answer, there are only 40 students are there. So those who are joining late, I'm giving them clear instruction. Don't be late. Otherwise, next time onwards, I will take attendance in the beginning, and then after I will not going to take the attendance at the last. Okay, so you will just suffer from the absenteeism. So please be on time. Do that practice. I'm open for the question. If you have question, ask me. Otherwise, make your summary in the chat box. Write your summary in the chat box along with your enrollment number and name. Yes, Sunita Ben, tell me. Sunita Ben, you have raised the hand. Sunita? Okay, so I'm leaving. We will again going to meet in our next lecture. Okay, goodbye. I have a next lecture also. Bye bye.